Welcome everyone to the week 4 assignment session. I am Rati Ludhani, pursuing PhD from Department of Mathematics, IIT Bombay. Today we'll discuss questions of assignment week 4, assignment 2023. So it was due on last Wednesday, so I can discuss that. Okay, let's begin. Feel free to ask any question if you have. Okay. Which of the following regular expressions matches the language is in alphabet A is equal to 0, 1 set consisting of words which contain an odd number of ones. So what it is saying, so you have alphabet set to be just 0, 1 and the language set has, so I'll denote it by L. Okay, so L is, or maybe just calligraphic L. L is the set of all the words. So what are words? Words are the sequences of finite sequences of 0, 1. Okay, so it's like the set W, just to recall. W, the set of words, is actually set of words of A, or to explain it, we can write with just 0, okay, with nothing, 0, 1 or 0, 0, 0, 1 and 1, 0, 1, 1. So all the finite sequences you can form with 0, 1. So there is no limit on the length. Okay, it could be 0, 0, 0, 0, 1, 0 or 1, 0, 0 and so on. Okay, so length could be anything, but it should be finite. So this is the set. Now so we have to consider the language consisting of words such that it contains an odd number of ones. So odd number of ones, so I'll write W contains odd number of ones. So that means you can have something like that, you can have something like that, you cannot have this, right? 1, 1 cannot be here because it does not contain odd number of ones. So this is your set. Now this set of regular expressions. Now it has been asked which of the following will define it. So basically it has been asked for which u L is equal to LU. Okay, so what does that mean? If you have seen the notes, so LU is basically LU is the set, all those W belongs to W such that W matches U. W matches U means it, so for example in our question, what do we have? We'll just take the scrolling vertical. Yeah, so what do we have? So for example in the first part you have U to be 0 star 1 0 star 1 0 star and there's again star. This is your U. Now what they are asking, so you have all the W's which is of the which matches U. Okay, so firstly let's check if that element has odd number of ones or not. Okay, so so we have all the W's which matches U. So you have 0 star. So firstly let's check what is this. So you understand what is a star? A star is for repetition. So for example you can have 0, or so 0 star means repetition of 0. Maybe it could be empty, it could be one time, it could be two times, or wherever. So it's like 0 raised to power m, where m belongs to n. So just to understand, it is of the kind n 1 0 raised to power, for example m and q, and there is some, so okay. So you understand this notation? What is star? This vertical.
Yes, ma'am.
Okay, great. Then I don't need to explain. Very good. So so let's check if it has odd number of ones or not. So okay, this is not vertical line, this is 1. Okay, yeah, I should write like this, otherwise it will be confusing for vertical bar. So you have how many ones are there? So you have 1 here, you have 1 here, and there is a star here, and there is nothing on this. Okay, so it's like 1 will be there, but this star will make it whether it will be here or not. Okay, so here, but number of times 1 is occurring in this part is just 2 times. Okay, so that is even, right. 1 is occurring 2 times, which is even. So whenever you take this star, so what it could make, either it could be just 0, either it could be 2, either it could be 4, either it could be 6. So anything but even. Okay, so you have from this part you will get even number of ones. Now from this part, how many ones you will get? Just 1, right? That is just 1, which is odd. So even number plus 1, that will become an odd number, right? So this, yeah, so this u will be will have all the w's, which not all the w's, I'm not saying like that, I'm just saying even in the question, yeah, so it is saying consisting of words that contain an odd number of ones. It is not saying this is all the collection. So I should write subset. That is a better thing. So you have L to be a subset of all the W's which contain odd number of ones. So when you take this U, then LU will contain will contain odd number of will contain words which has odd number of ones. Is that clear, this first part? So this is a correct option. Is that okay?
Yes, ma'am.
Okay, great. So let's check about the second part. U is equal to 1 star 0 1 star 1 star 0 1 star, and there is again a star on it. 1 star 0 1 star. Okay, this is the part. Now check, do you have so you have to check what will be LU. So if in this LU, if you can find out some element, some word which has even number of ones, then you are done. And if you cannot find it, then this must be a set containing words only of odd number of ones. So let's check. Can you give an example, or can you tell me, will it have odd number or even number of ones only? Like
the bracket star containing odd number of ones.
Yeah.
And the repeated times means it's odd only. And odd and plus 1 again even plus again 1.
Yeah.
Odd only, even only it comes.
Okay. One more thing. When you are saying about this, for example, let's check what does that mean.
Repetition.
Yeah, repetition. Just think of this part, nothing else. Here you have 1 star 0 1 star 0 1 star. It is not guaranteed will it be repeated even number of times or odd number of times. It could be repeated even number. For example, you can write 1 1. You can, in other word, you can have at this place 1 1 1. So it could be repeated even number of times or odd number of times. So you cannot say overall will it have even number of ones or odd number of ones. So you just need to have, can you find one word which has even number of ones? Then you are done. Like you can say this cannot be a correct option. So for example, as you said, you just take you have 1 1 1. You just take 1 1, and for example, just take this. Okay, you have 4 ones here. So what I did, for the first 1 star, I take 2 repeated thing, and for this 1 star, just 1, and 1 star just 1. Okay, now for this star I just take just one only, so I'm not writing, I am taking one time only. And outside it I can, so I have this option. At this place I can either ignore it. Ignore means I'll just take 0. So star is the repetition which can also have empty thing. So you can just have 0 here. For example, you will not have anything here. So either you can do this, or if you want to just write one time, you can do that. I'm just trying to make it even. Here 0, and here again I'm just writing 1. So you have this, which is certainly so 2 plus 2 plus 2, 6 ones are there, right? 6 ones. So here it is guaranteed that you have at least one word which has even number of ones. Even number of ones. Okay, so one more example is there. As the set is this, so you can just ignore all the stars. Basically you just take empty thing. So this star is there, so I'll just ignore this star. So I will not have anything from the first part here. And then from this one star and one star, I'll again ignore it, and I'll just take 0. That is 0 is also there. So 0 is there. 0 belongs to LU, which is a word of even number of ones, because it's just 0. So you have no 1 here, so you have just 0 number of ones. So that is even. Is that clear? You just need to find one example.
Yes.
So this cannot
I
be.
mean,
Yeah.
in that video, Sai said the ending number is 0.
Ending number is 0. No, that is a different thing.
Ah,
That says
okay.
that is the question of number of not number, represent, or maybe represent all the even non-negative even integers. That is a
Ah,
different thing. Even integers.
okay, ma'am.
So it says like you are so what you are saying, this is all the non-negative integers. It's actually this is a regular expression which can be defined by LU. So this is the set LU, which where u is 0. Here 0 is there because you are writing binary expressions. So non-negative integers with binary expressions. So you are writing using binary expressions. So for example, for 2 you will write just so you will have 0 and here 1. So how do we write it? Powers of 2, 2 power 0, 2 power 1, you have something here. So you will have something here, 2 raised to power 2. It's like that. So that is the representation. So when you have to write 2, you will write here, you will have to take 0, here you will have to take 1, right? So the representation is 1 0. So why sir said this should be 0? Because this is an even number. So this place is what? Coefficient of 1. 2 raised to power 0 is coefficient of 1. So we are saying it cannot be 1
1.
because that will be plus 1, because all the other things is a multiple of 2. So the last one will decide even this is a even number or odd number. So if this is 1, then plus 1 factor will come, that will make it even. So it's like 5 7. So that has to be 0. So that is from there. And for the other things it could be either 0 or 1, and there could be a repetition. And we write 1 also because we are saying we are not writing 0 0 0, we are not starting with 0, otherwise it will make multiple representation of the same number. So for example, if you want to write 2, you can write 1 0. If we allow 0 0 1 0, then there will be a different representation in this thing. So we don't want to allow that, so we are saying 1 should be at the first place. Now if we take this representation, 0 will be missed, so we will take 0 also, so or 0.
Mm.
So that was the thing he was saying. Yeah, that is not
Yes, ma'am.
related here, because it's just a representation of even integers. It is something else. We are asking number of ones in the words. That is a totally different thing. Okay, is that clear?
Yes, ma'am.
Yeah, so tell me about the third part. What can you say about third? So second is not.
Once.
Yeah. So for the third part, what do we have? This one. So you have 1 star, 0, 1 star, 0 star, 1 star, 0, 1 star. Can you? So here you can see there are. Here, what is the observation? On 1,
Same.
yeah. Uh, Sorry, can you repeat?
Similar to two.
Yeah,
1 star. Even not guarantee for even times or.
yeah. And even for an example, whenever you are explaining something, and if you are saying this is not true, just give an example. That is enough. So, for example, you just take there is nothing here. You can take 0 number of times, so that is empty one. Here, so the key point is every one has star. So that means it could be repeated,
Mm.
and that will make it variable in in the sense that it could have odd number or even number of ones. So you just ignore. So this is star, you can again ignore this star, you again ignore. So you just have 0. Again you have 0 in your LU,
Mm.
so that will make it. And you can take more examples, but you can in particular take 0. So this is not correct,
Hello,
but
ma'am.
yeah.
Ma'am, one thing.
Yeah.
If I want to express odd number, um, consisting of words that contain an odd number of ones. Okay, ma'am. Sorry, I thought it's only odd number. Okay.
Okay, sure. Yeah. So I hope this is clear. Then what about the fourth part? You have now you have, so this is the one, 0 star 1, 0 star 1 star, 0 star 1, 0 star. So 0 star, we don't care about this. Now let's see this ones. There are 3 ones here. So what can you tell me here? Will it contain only odd number of ones, or can it have even number
Odd
of?
number.
Yeah, can you explain?
Odd number of ones because in bracket star now 1 0 star 1. So we repeated even times 1 only comes
Yeah,
and the outside is only 1. So
yeah,
even plus 1 1
exactly.
equal to odd number.
Exactly, very good. So we have even number of times, and star will make it even or even, like we'll repeat even number of times. So that doesn't matter, it will make it even only. And here you will have odd, and in total you will have odd number of ones. Very good. Okay. And always check 0 is there or not. If 0 is there, then there will be a problem. So even if in this condition you have 1 1, and so for example, just as an example, if you have 1 and let's say 0, and you have this, maybe 0 and 0 star, like this. uh, oh, sorry, no, yeah, that is not enough. Yeah, it is understandable. Okay, I'll just trying to have some different example, but yeah, it will again make it, because 0 is there, so there will be a problem. So 0 is there, or you can just have 102 times repeated, and so you will have even number of times. Exactly, that's okay. Okay, so this one is correct. Okay, is that clear, this question? Okay, let me know if you have any doubt.
Yes, ma'am.
Okay, great. Let's see this next question. Let u is equal to 0 1 1, and this is star. So you have u to be equal to this. Which of the following regular expressions matches the languages in alphabet A consisting of words? So you have L to be and alphabet set is given to be 0, 1, consisting of words all the w's such that w is equal to w1, w2 up to and so on wn, such that w2i is equal to 1 for all I greater than or equal to 1. What does that mean? You have w2, w4, w6 and so on is equal to 1. So all of these are 1. So you can have something like 0 1 0 1 0 1 like this, or you can have 1 1 1 1 1 1. It is not guaranteed about the odd number of places, but the even number of places should be equal to 1. That is the condition. So you have all the words of this kind. So they are asking for which. So I'll write this to be v. Okay, these are v's. Let's say for which v. Okay, this is something they're asking. So L is equal to LV for which v. That is your question. Okay, so in your first part, let's take v to be u. So they are asking, if we take v to be u, will this give all the w's with this condition? So let's check. So LU, you are checking about LU. So you just try to find all the words. So for checking, what do you need? What you need to see? Do you have words which are in LV but not in LU? Okay. So if you can prove that LU is equal to LV, then you are done. Otherwise, there should be an element in LU which is not in LV, or the other way around. It could be anything. You just need to check for which you can have or for which part you can have the requirement. Okay, equality. Is the question clear?
Yes, ma'am.
Okay. So let's check what is for LU. U is this. U is equal to 0, 1 and 1. So they're asking it has all the words with this condition. So certainly 0 is there, because with 0 2i is not here. So you can have epsilon, like empty set. Okay, so that is there. And it is there, it is here also, because there is star. Okay, so you can just ignore like you will just take 0 number of repetitions, that is just the empty set that is there. Okay, what about the other thing? Can you find an example, or can you give an example for which this is not possible? Or maybe some word which is in LU and W is not in LV, or W belongs to LV and W does not belong to LU. I'm saying that there is one W at least, which I can say you can take this one maybe. So W belongs to LV, means in this set, or maybe I'll write L. Okay, okay, let me write this, that will be better, so there will be no confusion. I'll just write V, not U. U is here, which defines V is equal to U. So L I'll write for this set, and LV I'll write for this set, like which we are trying to calculate. So if V is equal to U, then you are searching for such element. So you have LV and you have L, you have L and LV. So let me give you the hint. So for example, if you take U is given to be 0 or 1 and 1. So here there is one element here, there is one element here. So there are total 2 elements. Now there is a repetition. So it could be 0 2, 4, 6, 8. So all the elements will be just of even length, right? But in your question it could be like just 0, 1, 0. So for example 0, 1, 0 belongs to L, but 0, 1, 0 does not belong to LV, or which is LU in this case. Is that clear? So what we did, we just did like you have to check. So the question is L is equal to LV. I'll change for which V L is equal to LV. This is your question. Okay, now in the first part, if so first part says take V to be U. If V is equal to U, that is equal to 0, 1, 1 star, then if V is equal to U, which is this, then 0, 1, 0 belongs to L, because at the even number it is 1, so it's this is okay. So what does this say? At the even places it should be 1, all the words which has this condition. So this belongs to L, but 0, 1, 0 does not belong to LU, because LU have only even number of have words only of even length. So because this is like 0 or 1, so there should be 0, and now at the second place you will have 1, then you can have this, you can have 1, 1. So for the first place there is a choice, and at the second place or even number place it is 1. So it satisfies properties of W, but there is a problem that it is always of even length, because this is this itself 0, 1 and 1, this is of even length, and you have a star, so it will be repeated just the even number of times. So that is the problem. And so so this LU is certainly a subset of L, but not equal. Is that clear now?
Yes.
Okay, great. So that's why this is not the right answer. Let's check about second part. So if V is equal to, V is given to be 1U. So take 1U. Then that is like 1, 0, 1, and you have 1 outside, and you have star here. Can you tell me, will it be equal to this or not? Or can you find some word which is not in any of them and it is there in other one? Here you can find a simple example.
Yeah, so 1, 0, 1, 1. So 0 in the second position, which is not allowed.
Yeah, okay, exactly. Very good. So yeah, you have the problem is at this place you can have 0, which is the second place, or next one will be the fourth one. Yeah, 1, 2, 3, 4. Yeah, so that is the problem. So 1 is making a problem, creating a problem. So exactly 1, 0, 1 belongs to L, but LV, but does not belong to L. Very good. So this is not the correct answer. Let's check about the third one. If V is equal to U01, you have U01, which is like 0, 1, 1, and you have star here, you have 0 and 1. Okay, let's see about this one. Okay, here can you tell me anything? Okay, I have written it down correctly. Yeah, yes. So this is your OR, Here is or and there's a star. Yeah. What can you say about this one?
So if I say 0, 1, then 0,
Yeah.
then again 0. The
Then
fourth one is also coming from. Oh no, okay.
there's a star. Yeah.
No, no, no. Okay, first I have to. So 0, 1, 1, 1, 0.
Yeah, exactly. So the point is you cannot find an example because this is actually uh, at the right position. So basically this one is making it, this one is coming extra, but this one, this part is exactly, this place is blank, like 0 or 1 could be there. At the second place it will be 1. At the fourth place it will be 1 because this is just this star.
Yes.
So at the even places it will always be 1, and there will be some word at the end which will make it of odd length. Just that is the problem. So now you will have so L V is contained in L, but not equal to L, because you cannot have something of this kind. 0101 belongs to L, but 0101 does not belong to LV. What is the problem? Because this says that this is of even odd length. So the problem is you cannot have even number of like even length words in this set. In LV you cannot have even number, even length words. That will create a problem. Is that okay? This will be a subset, but not the. This will be always a proper subset. Is that
Then,
okay? Yeah.
ma'am,
Yes.
how to how to choose if it is, if we think this for our convenience we take 0 1 even times.
Yeah.
Repetition means
Yeah.
sometimes how that answer will be correct.
Sorry, I didn't get your question.
Yes, suppose
Can you
we
tell?
odd time. If star means we can take odd time and outside is one and
No, this.
even will come.
Yeah, this one is saying. So you are saying for this third part, right?
Ah,
Yeah, so you have this. Firstly you have this u, which says at this place there will be an option of 0 or 1, so you can have anything. At this place you will have 1. Now there is repetition of this part. So for example you can have 0 1, you can have 1 1. So at this place, at the even number of place, you will have 1 definitely. So you can have again 0 1, and there's a star, it says it could be repeated n number of times. So here this one, 1 2 3. So this is so I took dash 1 3 times. Okay, here there is an option, so we can have 0 1 or whatever. Now what they did at this, with this there is some there is one word sorry, one letter is coming into picture, or maybe one alphabet is coming into picture. It's just this one place which says that you can have at this place either 0 or 1, because this is an or option, right? So
yes, ma'am.
whatever you will have, the length will be odd,
Mm.
because this one is even this one is of even length, 0 2 4 6 8 whatever, just the even number. And now this place will make it odd, and there has to be a one, has to be one place. If you have, if they have written not or maybe if they have written a star, then there will be a different condition with that, because with this star it will become either 0, so you can remove it. With 1 you can have one place, so it will have all the even and odd number of places, so that will not be a problem. But at this place we again have to see, will it at for even at even place there should be a 1, then there will be a problem at this position, because they can have 0 1 0 1 0, and at this place it will not be 1. So with the star also there will be some problem, but the point is there is nothing here, so this place is making it odd. And so we are not having even length words, and that will create a problem. Is that okay?
Yes, ma'am.
Okay, so let's check the fourth part. That is u 01 u01 or u. So yeah, or u. So what they did now just see, so what they did, this is what you have from the previous part. So this is your third part, and now you have this one. So if you see, this is your first part, so you have all the even options, you have all the odd options. There is an or here, or. So you can either have odd one or you can have even one. So actually in this part, all the possibilities have been considered. So lu, which you have seen earlier, and lu01. So you earlier you have seen that this is the proper subset, but now combinedly, so you can write, so I should not write plus in between because these are sets. So as a set, I can take union. So this combinedly is equal to L. So combinedly means because you have taken or, so either you can have the first part or second part. So actually this is making it all the options which you need. So this is equal to your L. So L u01, this, yeah, this is equal to L. Is that clear?
Yes, ma'am.
Okay. So this is the correct option. So this is like constructive, if you see u1 u1, like constructive options. Okay, great. Let's move to the next question. Let W be the set of all words. So W is the set of all the words. So from the alphabet W with, or maybe I'll write, I understand that A is given to be AB, and W is the set of all the words from A, alphabets at A. For the regular expression U, so you have U to be equal to A star B, and you have B star A, and you have star outside. Yeah. Oh, there is a or option in between. Every word in LU, so you take LU where W matches U, matches U uniquely. So this is a statement which they are asking whether this is true or not. Okay, so can you tell me what do you think? So you have U to be this, so what will be the will LU be set which matches with U uniquely? So basically you need to check whether this is these forms the unique expressions or not, because LU is a set always. Okay, but the point is whether this regular expression set is coming out unique or not. Okay, so unique means you understand uniqueness in this case, right? So
Yes,
basically,
ma'am.
yeah, okay, great. So but uniqueness means, for example, you have like this, then A belongs to this, or A belongs to A star, but this is not unique because it could come from this one or it could come from this one. But for uniqueness, what we have considered, so A will not belong to here, uh, uh, because from the definition we are asking unique, uh, like, so basically it has all the words which has unique expression. So A belongs to A, okay, not this. So A can be A, or A can be from A star. Okay, but not both. That was the condition. So I'm just trying to write, or maybe I'll write A is equal to U or V, but not both. A matches U or V but not both. That is the condition which we are asking. So here in your question, let's check what do we have, what do we need to check for the uniqueness part. So you have A star B and B star A. So here a star is there. So firstly check what do we mean by, so here you have or here. So or is the key thing which can create a problem. So you have A star B and you have B star A. So either you can have, so you have A star B or you can have B star A. Main thing is here B and A. So the ending is B and the ending is A. So it cannot match firstly. So for example, if U is equal to A star B, or so basically there cannot be any W belongs to such that W matches A star B and B star A simultaneously. So basically simultaneously means, or I can just remove that, there is not a requirement. I have just written and. So A is either so it is matching with A star B and B star A. So W match with A star B and B star A. So it cannot be a possibility because B is at the end and here A is at the end, and these are two different things. So you cannot have such kind of thing. Is that clear? You cannot have multiple options to come up to match with W. Is that clear?
Yes, ma'am.
Okay. So this is actually a true statement. So for an example or as an exercise, try A star B and just remove or in between. Actually it will not be a question, but still if for example you have something like that, okay, so there you can have B star and here you have B. So for example you can have A star B and from this part you have 2 times B, and from this part one time you can have this, or okay, never mind, sorry. So it's very a cumbersome example, so exercise, let it be. So basically what I mean to say, you cannot have two expressions. So you cannot have W cannot match with both of them simultaneously, and you have star. Just try if you can so for example you can have A star B and from the other part you have B star A. That could be a possibility, but whenever you have the ending matters. So this ending is making something making it unique. Okay, so yeah, okay, I hope this is clear. You can try to write rigorously if you want. Yeah, okay. Okay. For a regular expression U, so true or false question. For a regular expression U, the generating function LUX is rational if and only if every word in LU matches U uniquely. So LUX is rational. What do you think? That is from the notes actually. If and only if every word in LU matches U uniquely. What about this direction? Or maybe I'll write this direction. So if every word in LU matches U uniquely, will it be rational? Will the generating function be rational? Okay, this is coming from totally from notes. Okay, 1 second. Yeah, here for example, Okay. Yeah. If words in LU matches U uniquely, then LUX is a rational function of X. This conclusion thing. So conclusion says, so this direction is okay. So LUX will be a rational function of X. Let us see the other direction. So other direction says, uh, every word. So if LUX is rational, will every word in LU matches U uniquely or not? So that is also here. That is actually coming from automaton. Sorry, automaton. Yeah. So mm, yeah, let's see. There's an example, if I remember correctly. Yeah. So if you take this L from the pumping lemma, uh, in the in the notes from pumping lemma, so if L is equal to 0 power n 1 power n, so if you take such kind of function, so if you have such kind of functions, okay, if you have Lx, so here this is a rational function, right? So this is a rational function. Now, but from the pumping lemma, you can prove that this is not a language accepted by an automaton with p states. Okay. From this lemma, you can get this information, and from this theorem, Kleene-Robin-Scott theorem, that if a language accepted by a finite moton and languages uniquely matching a regular expression, these are equivalent thing. So if you cannot have this, you cannot have this. So that is an example. You have a rational function, you have a regular expression with you have a rational function, but there is no language accepting this, uh, accepted by an automaton with p states, and this implies that you cannot have a regular expression which can using which you can write this language uniquely. Is that clear? So these theorems given an example. Is that clear? So pumping lemma example, or maybe Lx is equal to 1 by 1 minus x square, and plus Kleene-Robin-Scott theorem. Okay, is that clear? So this is a false statement. I can repeat if you have any doubt. Please let me know. Okay. Yeah, sorry. This is not for this, is for this, and this
Yeah,
one. Yeah.
actually, can you repeat? Because actually, thing was, I wasn't I wasn't attending this course from the very beginning. So actually, I did not look into this material properly. I'm only joining very late in this course. That's why.
Yeah,
Sorry.
so that's why I've written so basically I'm saying for this example, so this is coming totally from notes. You can read it, and if you have any doubt, you can tell me later. That is okay with me. So basically what I was saying, so these are actually good examples and explained example in the notes. That's why I'm just referring to it. So so here you have an example. So basically, if you have generating function of this kind, so from pumping lemma you can prove that you cannot write it in a language accepted by your automaton with p states, and by this thing language, if something is not accepted, if a language cannot be accepted by a finite automaton, you can actually you can have the equivalence relation with languages uniquely matching a regular expression. So if you cannot write it in the fourth part, as a fourth part, you cannot write it in the form of first. Okay, that is what I'm saying. So that is a theorem by Klein, Robin, and Scott. So this is exactly the combined result from this example with this theorem. And the other part, if you have that is again coming from the notes. Yeah, this conclusion. If words in LU match U uniquely, then LUX is a rational function of X. So, if you want to understand that, you can just read the notes of regular expression, which is, I guess, week 4, first lecture, and the and the and and the lecture, I guess, fourth, or maybe just search pumping lemma, you can find that. So just go through that, you will be able to understand, or you can come back and always ask me. Is that okay?
Okay, thank you, ma'am.
Sure. Okay, so this is a false statement. Okay. Let U be a regular expression such that LUX is equal to 1 by 1 minus 2x square. Which of the following are not possible? So you have a generating function. Now they are asking, so it is again from all the equivalence, not all the equivalences, all the one second, not this. So if you have the regular expressions, then you can actually find the generating functions, this one. Okay, so okay, what I can do, I can actually copy paste. Oh, sorry. Oh. Take a screenshot is better, I guess. Yeah. Yeah. So we can use these relations to have our answer. So just tell me, so what will be LU when L, so if U is equal to AA BB star, then what will be LU? So just try to use these statements. So LUX, so what do you have? Okay. 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 LAABB star will be what? 1 by 1 minus LAABB x. From this fourth part, I'm using fourth part, then I can just for the star part I can have 1 by 1 minus LUX. So I'm just having this. Now what we can do, or part says, or part, this one, third one, or part says just write plus. So you will have LAAX plus LBBX. Now next what you can do, sorry, yeah, next what about LAA? Now the product. So product says you will write in the multiplication thing. So you will have LAX into LAX, and for the next part you will have LBX and LBX with bracket. Now you have, what is LAX? LAX, for all A you will have LAX to be yeah, one second, yeah, LAX is just x, and you have x plus x into x, there's a bracket, sorry, yeah, you will have 1 minus x square plus x square in bracket, you will have 1 by 1 minus 2x square. Is that okay?
Yes, ma'am.
So just use these relations and you can get the answer. So I am claiming that you will have this. So just go, these are simple. So you will have again 2, again 2. So you will have 2x square again. Here you will have x here plus x square. So that will make it, so this, you will get this in the denominator. That will create a problem. And similarly for the last part you will get this. So for this part you can have first and second only. Okay, so that's your answer. Is there any question? I'll just connect my charger to my laptop. I'll be back in a minute. Yes. Is that clear? This question?
Yes, ma'am.
Okay, great. Okay.
Yes, ma'am.
Yeah, very good. So let's move to the next question. Let RGWK denote the restricted growth words of set partitions with K blocks, as you have seen in the lectures. Let K1 is less than or equal to K2. For W1 belongs to RGWK1. So there's a restricted growth word with K1 blocks, and there is another word, restricted growth word with K2 blocks. Then which of the following is always true? So firstly, n could be anything. So we could be writing any element, any partition of any number of elements with K1 blocks and K2 blocks. Now, for example, just to recall, if we have, let's say 1, 2, 3, 5, 7, and 4, 6 belongs to pi 7, then what will be the restricted growth word? Growth word will be, so for first, so 1 will belong to first element. So basically restricted growth word tells the position of the partition, like position of the numbers. So in whether it is in first block, second block, third block. So here this is the first block, this is the second block, third block. So these are blocks. So we just need to write where 1, 2, 3, 4 these elements belong. So 1 belongs to first position, 2 belongs to the second first block again. So 1 is in the first block, 2 is in the first block again, 3 is in the second block, 4 is in third block, 5 is in second block, and 6 is in the third block, and 7 is in the second block. So this is the restricted growth word with three blocks. Okay. Now this is how we can get a restricted growth word corresponding to any partition. Now there is a recursive definition of RGW. So basically RGWK satisfies or can be defined by two things, if you remember. That is, if W belongs to RGW, if and only if K occurs in W, so the last block should be there. The first occurrence of I in W precedes the first occurrence of I plus 1 in W. So what does that mean? For example, in this, so the first occurrence of of ith block should be before the first occurrence of I plus 1th block. It cannot be possible like you have this. So this is not possible. So first occurrence should be always before the next number. And this is true because of this representation. We always write the first element, like the next one. So one is there, then the next least number will be in the next block. Okay, so using this, so we know that, or I can copy paste this if you want. So this is the definition. Now using this, can we conclude if W1 W2 belongs to RGWK2 or W2 W1 will belong or not? So in any case we need to satisfy these two properties. So we are having more number of blocks, or maybe K2 number of blocks with more partition, like partition of bigger n, okay, corresponding to these two partitions. So it's like if we are partitioning n1 element, square bracket n1, and we are partitioning square bracket n2, then we are actually partitioning n1 plus n2 in w1 w2. Okay, okay, so yeah, now if we concatenate, what will happen? So you have w1 and w2. So we should be able to satisfy these two properties. So w1 w2. So, yeah. Hi Malakshmi. So I've started. Yeah, no problem. So I've started this question, and I'll be quick with this week. Okay. So I was just saying, we need to check that if W1 W2 belongs to RGWK2 or not, or W1 W2 and W2 W1. So we need to use the definition. Definition says W belongs to RGWK WK if and only if K occurs in W. So when we take W1 W2, we know that so W2 belongs to RGWK2. So that means K2 this belongs to W2 belongs to RGWK2. That means K2 has been occurred in W2 for sure, because we know that this belongs, W2 belongs to RGWK2. So this implies W1 W2. So we can say that K2 occurs in W2, W1 W2. So because it occurs in W2, so it has to occur in W1 W2. Similarly in W2 W1. Okay, occurrence is fine. Occurrence is coming because W2 has it. Because K occurs in W2, so when we concatenate, it won't go anywhere. So K2 will be there. So when we concatenate, it will be there. So first is fine. Second is the first occurrence of I in W precedes the first occurrence of I plus 1 in W. So what does that mean? So the next number, the position, basically the block number, the next block will the first occurrence of next block and the first occurrence of the previous block. So the previous one will always before the next one. So it's like you cannot have this kind of stuff 1 1 3 2. The position cannot be like that. So to the first occurrence of the number which is lower than the next one will always be before the next one. Okay, it could be possible like 1 1 2 3 and then again 2 is there, but the first occurrence will always be before the next number. So this is that. Now what will happen, you know that w1 has this property and w2 has this property. Then when you take w1 w2, now you need to check the first occurrence of, so k2 has all the values, so we know that this is something, this is partition of some n. So basically I have explained why this is n1. If this is the partition of n1 and if this is the partition of n2, then this is the partition of n1 plus n2 with k2 blocks. So we know that this is coming with k1 blocks, this is coming with k2 blocks, so it has to be in k2 blocks because all the numbers are there. Okay, you will not have bigger than that, so we have k2 blocks. So yeah, I hope this is clear. But this w1 w2 is a partition. So yeah, w1 w2 is a partition of n1 plus n2 with k2 blocks. Now from the definition, so from what we need to check, the second property, the first occurrence of I in w. Now you have this w1 w2, the first occurrence of any element, first occurrence of any I will precede the first occurrence of I plus 1 in w, because it will happen because it is there in w2. You know that in w2 or maybe like till k1 w1 will handle the property. Okay, w1 has this property that I will always precede, the first occurrence of I will always precede the first occurrence of I plus 1. Okay, so till k1 this w1 will handle because this belongs to rgw wk1, and for k1 plus 1 up to and so on till k2, this will handle rgwk2 because this belongs to rgwk2, so this will handle the rest of the property, like rest of the numbers. So this will be there. And similarly when we take w2 w1, then we don't need to check anything because w2 has all the occurrences, because w2 in w2 all the blocks will occur. Okay, now the first occurrence of I will always precede the first occurrence of I plus 1 in w2, so it will happen in w2 w1, so this will belong to rgwk2 also. So both of these will belong to rgwk2, so this will be true. Yeah, is that okay?
Yes, ma'am.
Okay, let's move to the next question. Let w be the set of words in alphabet set A is equal to ABC. There it has been asked, there exists a regular expression U such that the language LU consists of the words W belongs to W with A and B occurs same number of times. So this is some kind of like ties question. So if you have seen this ties example in notes, ties example in notes, that will that is similar to that, because there the alphabet set is H and T, and you have been asked the occurrence of H and T is same. So if you take that set, that is so in that example you cannot find a regular expression because that is not rational, because the generating function is not rational. So from there we know that if it is not rational, you cannot find a regular expression, as we have seen a true false question earlier. So here what you so you, here again you have to check can you get a regular expression or not. Let's try to find what will be the sequence. So what will be the number of elements. So this is a combinatorial class, so what we really try to find what is ai, what is the cardinality of ai, because you know that generating function will be cardinality of ai x raised to power I. So this is your generating function. Okay, so just try to find what will be ai. So and so you know that the length is the length of the words is your this the function is the length of the words. So you need to check, if you consider this much length, how many elements will occur of this kind. So for example, if you take just a0, you will not have anything. It's just like empty set, so that is one element. When you take a1, so a1 is you will consider one element. Now you know that a and b has to occur same number of times. So you cannot have either a or b, because if a will come, then b has to come. So you can just take c, because c is there, c has no restrictions. So you have just c. So this implies cardinality of a1 is just 1. So what I am looking at, the length is fixed, so you have this length, and how many elements are there in LU with this condition. So let's see what will happen with a2. A2 will be what? A2 is number of elements. So you can have, firstly let's just take cc, you have both the elements cc. You can have, now if a will come, so one second. Yeah. Yeah. So what I was saying, when so for a2 is you have length 2, and now what are all the possibilities in this set LU? Okay, so a and b has to occur same number of times. So what you can have, either there is no occurrence of a and b, so you will just have c and c, cc. Now if a will occur, then b has to occur. So there is no option for anything else. Now what you can have, you can also have ba, because these are two different things. So these three elements will be there. Similarly, when you go to a3, you will get, you can either have all three c, you can have ab, then the third element could be a, oh sorry, not a. Now again a and b has occurred. So or maybe I'll write, if you just have c, now the second place, let's take a, then the other place has to be b. Similarly, if you have cba, now you cannot have so if a will occur, then b will occur, so it will come in pairs. So either it will have even number of cardinality with a and b, or it will have even number of cardinality. So the other places could be just c. So so there is no other option. Oh sorry, there is one option. You can have c to be switched. So there could be possibilities with so for example, you can have abc, you can have acb. So with you just take all the permutations. So you take cab, and you just take 3 factorial possibilities, right? So you will have 6 possibilities in this case. So 6 plus 1, 7. So I'll write ABC and its permutations. Is that clear? So
Yes, ma'am.
A3 will have, very good. So A3 will have 7 cardinality, and this will be your 3. So this is the way to do that. But now we need the concrete cardinality, because we need to figure out if this is a rational function or not. So what will be an? So I am writing something. So an will be if n is even. So what is happening, or maybe I'll write an even or odd later. So what will happen? So basically, if you don't have anything, then you will put C. Okay, so you start with A, and so basically what we are doing. So firstly we have not considered any A and B. Okay, so you just take all C's. So that is one possibility. So basically what you are doing in N, you are not choosing any position for A and B, so you just take N, choose 0. Okay, similarly for B, you are not choosing any possibilities. Now you choose out of n, you choose. So this is the first part. Okay, so CCC, all the same, you just have one possibility, CCCCC. Now you consider one occurrence of A. So n, choose 1, you choose one position. Now out of n minus 1 position, you choose again one position, because A and B has to have the same cardinality. This is corresponding to A, this is corresponding to B. So yeah, and rest of the elements will be C, so we don't need to put anything. So we are assuming with these possibilities, the remaining places will be just C. So there is no other possibility, so it's just 1 into 1. So there is no requirement of writing for C. Now you choose n, choose 2 positions for A. Now out of n minus 2 positions, you will have again 2 positions for B, and the other positions will be just C. Other places will be just C. So you go on like that, and you will have till when you can go. You know that A and B has to occur in like half, as in if A will occur, B will occur. So basically A can go up to n by 2. Okay, so n, choose n by 2, and then n minus n by 2. So basically that is again n by 2. So this is happening if n is even. N by 2, choose n by 2. So basically you have half positions with A, half places with B, and there is no occurrence of C in this case. So this is happening if n is even, and this will be again n, choose 2 and n, choose 0. The same thing will happen, but at the last place there will be some correction. So when you take n, choose, now you know that if it is 5, then you can go up to A. For A you can have just 2 places, and then again 2 places for B. The positions could be anywhere, and the one place will be just C. So you can go n minus 1 by 2. You will just have 2 positions, so you cannot have the last one. So you have, because this is if n is odd. Now from the rest of the places, so rest of the places will be 3. So that will be n plus 1, choose 2. Sorry, n plus 1 by 2, and you choose n minus 1 by 2. And now one place will be just C. So this will be the cardinality. So I'll write as an exercise. Verify that an, or maybe summation an, x raised to power n is not a rational function. So there is some combinatorial things coming up, and you can actually verify that this is not a rational function. Just try it out. Okay, so this is not a rational function, so this statement is false. And you know that if this is not a rational function, then you cannot, there does not exist a regular expression with this property for this LU. So there is no U for this, because if there is a regular expression, then it has to, then you can write it unique, you can find U uniquely, and then you can write, then the generating function will be regular, sorry, rational. Okay, is that clear?
Yes, ma'am.
Okay. Let's move to the next question. Which of the following regular expressions match the word a square b square? So you can just see which of the following expression will match a square b square. So let's see, can we get a square b square from these? So here let's take a, so you can have some power, okay? So can you tell me, can you write a square b square with some star value? Like you can choose any value for a star. So for example, if you take star to be just 1, then you will have such kind of things. So you will have a square b. So what is the problem? You will so these, if you see, these are even, but here whenever you will take, you will have a, this is even, there is one a which will create a problem. So whenever you will repeat it, so you have ab star, ab star, then this and this will be even. So occurrence will be either 0, 2, because ab has length 2. Now ab square will have length 4, and you will get even only. Now this is even, this is even, but this is odd, so total will be just odd length, and so you cannot get even length from this. You need even length, so this is not possible. What about second? ab star, a b star. So here if you see, this is even, and now this is 1, okay, odd. Here again you have odd star, so you can have either odd or even, because if you repeat odd 2 times, then it will become even. So the whole sum could be odd or could be even. So there's a possibility to have a square b square. Okay, let's check if we have that. So you need a square b square. So let's see. So from the first part you take ab, here you just take a, so I am just repeating one time the first one. Okay, the a is coming as it is. Now you have star on a or b, so you can have whatever you want. So with the first one, so you repeat it 4 times, because you need that. You repeat it 4 times and you take a, so this is coming from this. You take a, b and b, because the options are a or b. So you can so you repeat it 4 times, and with every option whatever you need, you just take it, because this is basically all the words. If you, this is all the words, if you want to see that, because you have option for every place. If the set is just a and b, the alphabet set is like, if you have a to be a and b, then this is all the words. This is the set of all the words, because at every place you have 2 option and you have given that. Is that clear?
Yes, ma'am. Ma'am, A dot B star means
Which one? This one?
in definition we write now OR function and AND function.
Yeah, yeah.
This is A R B.
Yeah,
So
yeah.
we can A B B
Yeah, yeah.
and uh,
So this is basically a or b. So for each place, so you can, so I'm saying I'll repeat it 4 times, which is required. So I'll repeat it 4 times. Now you, at every place you have either a or b, either a or b. You can write anything, either a or b. So you have both the possibilities. So as the requirement says we need a square b square, I'll choose a here, I'll choose a here, here I'll choose b, here I'll choose b.
Okay, ma'am.
Yeah, so or says you can choose anything at that place out of these two options.
Okay.
Okay, so
Yes, ma'am.
this is the right one, second one, and there could be more because there is a square box. uh, yeah, and let's see. So for example, third one, what will happen? So you have,
A not correct, ma'am.
this is not correct. So BA star, yeah, same reason you can give odd length, right?
Mm.
You can
Mm.
give, this is even, the middle one will make it odd. Okay,
Yes.
and okay, again this is not showing. So, okay, yeah, so and the last one again you have the same thing. You have
Yes, ma'am.
B or A. Basically what you can do, you can even ignore this. There is no requirement of the first part. So first part you take the empty one because there is a star. Now you take A, and now at this with this BA star, you have all the possibilities. So with BA star, once again, why this is lagging. I'll share again. Yeah. Yes. Yeah. So yeah, what I was saying, yeah. So you have so in the fourth example, in the fourth option, you can just ignore AB star. You can, yeah, sorry, BA star you can ignore. You just take nothing from there. You just take A from the second, which is really need to. We have to because there is no option where there is no star on it. Now with B or A option, B or A star, you just take all the possible, all the requirements. So you take B A A B B. So you just repeat it 5 times, and at each place you have the option of B or A. Just take B A A B B. So you will have your option. So yeah, fourth is correct. Okay, let's move to the next question. Yeah, true or false? The regular expression 1 or 0 star, so matches with the word 10101010 uniquely or not? So what do you think?
Yes, correct.
Yes, no? Yeah, exactly the same reason. Firstly, this will map it uniquely because one is fixed, so there is no other possibility. So at first place it will be 1. Now at rest of the places, which is 3 plus 3 and 7 places are there. So at 7 places you have you have fixed possible, you have fixed requirement. You will put 0 here, 1 here, 0, 1, 0, 1, 0. So at these places you have, so basically star will, you will take for 7 times repetition,
Yes, ma'am.
and at each place you will take 1 or 0. So you will have that. So basically this is true, right? Exactly. Next one, the restricted growth word of the partition this. Can you tell me which one? So you just need to find
1, 2.
Yeah, 1 is coming in first one. So first block, second block, third block, fourth block.
Yes.
Yeah. 1, 2.
2, 1, 3,
Yeah.
4.
No, 5. Now 1, 2, 3, 4, and now fifth, the number 5 will come in third block. Yeah.
4.
Yeah, 4, 6 is there. 7.
1, 4.
1, 4. Exactly. Very good. So you have first one as your answer. Very good. Let's move to the next question. Yeah. Find a regular expression U such that LU is same as the language accepted by the following automaton. So you have this. You need to find a regular expression U such that LU is same as the language accepted by the following automaton. So if you have seen the process, you just need to find how it is moving ahead. So so accepted by the following automaton means you will start with initial state, you will come back to your accepted state is what, where you will end it. So there are two accepted states. So out of that there is no line which is not going out of these accepted states. So accepted, so if you have q2 and if you have something like q3, basically accepted state is also represented by the double line. So this double circle itself says this is a accepted state. So if you have such kind of thing, then q3 could be accepted state but not q2. Okay, so for this accepted automaton, so now for this question, let's think. So you start with q2. Okay, so you have to just give which regular expression will define this. Okay, you start with q2. Now you first go to 1. So you can go to using 1. So you start with 1. So there is other possibility with 2, we will take it later. So basically you can take or 2, but first start with 1. So there are two options. Now with 1, what will happen, you will go to this state. So after 1 you are just repeating yourself at 2. So you just take 1 2 star. Okay, now and for the second one, what is happening, or you can go with 2, and at this step you will have 1 star. So you can repeat 1 star 1 star 1 star, and there it will end, because these are accepted states. So these two options could be, so this will come with or. So let's see what do we have. So this is your fourth option, right? So for the other options you can directly see, for example with 1 star 2, that cannot be a possibility, because when you move to 1, so I'm looking at the third option. When you move to 1, then you cannot go again 1. Okay, there is no possibility of 1 star 1. When you move to 1, then there is no outline from q2 which is going with 1. So because that is just 2. So 1 will occur, then next one will not occur in this situation. So 1 star cannot be a possibility. So you can just check like this, and you will have this answer with your question. Okay, is that clear?
Yes, ma'am.
Okay, so for example in the next one, what will you have? Now you need to find the generating function. So for generating function, again, if you can get u, then using lux you can find it out, as in the last question, because you have with multiplication, like with concatenation you can have multiplication. When you have or, you will add it. When you have star, you will take 1 by 1 minus lux. So if you use those things, then you will get it. So you need to find out what is your u. So u will be, again you do the same thing. So you start at q2, which is initial state. Then you have just one possibility, because out from q2 there is just one option. 3 is coming into q2. q0, so we cannot say this is outward. So you have 1, you start with 1. Now after 1 you have two possibilities, either you can go to 4 or you can go to 2. So basically what I'll do, you take 1 2 3, because when you take 1 and if you go to 2, then this is 2, then you, or you can have 3. Okay, so there is a cycle here, 1 2 3, that can be repeated many number of times. Okay, but when you do this cycle, you will not reach at the final state, at the accepted state, because accepted state is q3. So you will just in this loop, then to go to q3, when in whatever number of cycles you do, there it does not matter, but you will complete to 1 2 3. Now from q0 you will go with 1, and then from 1 you go with 4. So you have this, then you will reach at the final state. Okay, so you can either take the loop once or maybe just empty, you just don't take this loop. So for example, there are many possibilities. So the possibilities will be just either you go like this and go like this one, or you take this loop and then go like this, because you have at the end you will have to go like 1 4. So any number of cycles you do in this cycle, it does not matter, but at the end you will go from 1 4, because you need to reach at the accepted state. So you will be this. Is that okay? So LUX will be what? So you have seen that I'm using this. So I did that earlier. Yeah, this one. I'm using this one. Yeah, it's fine. So I'm using this one. So with OR you will add, with a concatenation you will multiply, with U star you will just do 1 by 1 minus LUX. So I'll do that only. So yeah, here is this. So what you will do, you have these three as multiplication. So you will with concatenation you will have multiplication. So you will have 1 2 3 star x plus L1x plus L4x. This will be 1 by 1 minus, this is, yeah, L123x. Okay, this you will have just x, because with any element of alphabet set you will have just x. I'm using those formulas. So you will have 1 by 1 minus. Now you have 3 concatenation of 1 2 3. So you will have L1x, L2x, L3x, and here you will have x plus x. Sorry, there is no plus here, there is multiplication, because we are in concatenation case, right? This is a concatenation case, so you will have multiplication, not addition. Sorry. So you will have multiplied x. So basically you have x square by 1 minus L1x is again x. So this will be 1 minus x cube. So this will be your answer. Is that okay?
Yes, ma'am.
Okay, great. So again the same question. So you will have again you find out the u, then you will be done. Let's try it out. So in this case again you see that there's a cycle on q0. So you can go 0 1, sorry, not 0 1, 1 0. You'll go 1 and then you come back to 0 using 0 to. So you have this cycle, because this will not do anything. There's a cycle that will definitely do this stuff. Now you have at q2. Now there are two possibilities. Either you can just go using 1. You can just go using 1. Okay, or what you can do, you can go with 1 and continue at 1. So you go with 1 and continue at this 1. Then you will reach at the accepted state. So either you go with 1 or you go with 1 1. Is that okay? 1 0 star is there. So yeah, is that okay?
Yes, ma'am.
So with both the cases, 1 0 star will make a loop and it won't bother anything. So again LUX you can calculate the same thing. I'll do 1 minus, so you have this 2, basically you will get x square, and here you have OR option, so you will have addition. With 1 you will get x, with 1 you will get x square, right? So you will get x plus x square by 1 minus x square. I've just calculated using those formulas. Okay, yeah, let's move to the next question. True or false? There exists a finite automaton such that the language accepted by it consists of words w is equal to w1, w2 up to and so on wn, such that
It's not visible. 14
oh,
question screen.
okay. Yeah, again I'll share again.
Just 13 question only it's showing.
Yeah, I got it. I'll share again. Yeah. Yeah. Now this is visible, right?
Yes, ma'am.
Okay. So there exists a finite automaton such that the language accepted by it consists of words w like this, such that at even places, so w2i is at even places, and at the third multiples of 3 it is 1. So basically you have been asked at the first position there could be anything, at second and third it will be 1 1, again fourth position could be anything, then 1 1 again. Oh, sorry. So you have multiple of 2, sorry. So you will have what? At the first position you can have anything. Okay, now w2i means firstly third position, yeah, sorry, second position will be 1, so w2 w4 w6, all these will, so basically first you can write at the even place you will have 1 firstly, and now multiples of 3 means this one, so basically at this position you will have 1, so 3 now 6 will be here. Now you have this position, and here you will have 1, and so basically we are just checking at what positions uh, we cannot write, we have options. So okay, so I'll write in this form 2 4 6 8 10 12 14, like this, that will be positions. Okay, and with multiples of 3 you have 3 6 9 12 uh, 12 16, okay, sorry, 12 16 15, okay, and so on. So what are the positions which are left? So 1 2 is there, 3 is there, then 5, then so basically all the positions with 4k plus 1,
Yes, ma'am.
right? So you will have after 5 you will get next number, you will get 5 6 7 is not there.
Coming now, ma'am. 9 is not that. 4K plus 1.
Yeah, 9 is there, so I'm just checking which are not there. Okay, still we this is not right. So 1 5 7, and the next one, let's see what do we have. 6 7 8 9 10 11 is not there, and then 12 13, so 13 is not there, so basically it looks like odd numbers right now. Yeah, so 13, after 13 you will have 14 15 16 will be there, 17 will not be there, right? And then 17 18
One more.
sorry,
6K plus 1.
yeah 16 plus 1, so basically this is something, uh, right, I'm just trying to find the pattern. So after 17 we will not have 19, and then multiples of 2 and multiples of 3 which are not there, so multiples of 2 or multiples of 3, right? After 19 you will get 23. Just trying to find just not yeah.
Alternating difference 4 2 4 2 4 2.
Yeah. Okay, 4242. Right. Hmm. So the difference is 4, difference is 2. Exactly, very good. Yeah. So difference is 4, difference is 2. Yeah, so there's a pattern. So basically why I'm looking at the pattern, if there is a pattern, then you can write it in the form of stars and everything. If that is just random, for example, this irrational kind of thing, then you cannot do anything. So pattern is required right now. So let's see what do we have. So as you said, so either it is like 4k plus 1 or it is like 4k plus 3. Okay, and or maybe, so how shall I write? Yeah,
And
so
case E
yeah, so
case means how even means 9 will come. So 4k plus 1 k is odd. That
yeah.
means
Yeah, I'm just trying to see the position repetition. So basically what is happening, this difference, so exactly as you said, what we can do. So at first position, so you have 1 2 3 4 5 6, 4 and 2, so it's like till 7 you go. 1 2 3 4 5 6 7. Now what I'll do, at the first position you have the choice, so choice will be from any alphabet set. So a is like your alpha 1 to alpha n. Then this is a finite alphabet because we are always in a finite set. So you have the options. So for example, you can have alpha 1 to alpha n, so you take the options at the first place. Okay, at the second place it will be 1, we know that. Third place we need 1 from the requirement. Fourth place again 1. At this place again you have the option alpha 1 to alpha n. Now at sixth one you will have 1, and at the seventh one you will again have the option. Yeah, okay, you will not write this. Yeah, the you just take this as your repeated thing. So what I am saying, you take this one. So what I have just taken, alpha 1 to alpha n, there is an option for the first place, and then you take 1 1 and again 1, you take alpha 1 to alpha n, and then at next step you have 1 and you repeat it. Then you will get your w. So w means lu. So this will be your u which is required. So how I did that, let's see, you have this difference of 4 and 2. Okay, so at the first place you will have this 4, after plus 3, when you do plus 4 you will get this, and then after this, so after this you will have this 1, and then you repeat it. So between this number and this number you have plus 2 gap, right? You have this 1, and then you will get back this because you have a star. So like this you will get the thing. Okay, one more thing. Okay. uh, yeah, these are some elements but not all, because you have, when you get one at the end, then you are getting all. Okay, so this is one option. Or actually what you can do, you have this 1 1 1 alpha 1. So you just take all the options. So there is this star, or you end it at this place. You end it at this place. So there is one at the end. You end it at this place, and in the last, so you take all four possibilities. Either one could be not okay. So what I am saying, you end it at this. So you have alpha 1 to alpha n, 1 1 1. You take alpha 1 to alpha n 1, and you take star. Now, or what you can take, you start with this one, 1 1 1, you take all the cycles, I mean, because this star says this will be repeated as whole. Okay, so this will be repeated as concatenated. So here you take this, so you took 1 1 1 and then this element and then this and then this. You take this as a cycle. I'm not saying this is the unique way, but you can definitely write in this way. So what I'm doing, I'm making all these elements in the end at once, at least once. Okay, so that what will happen, because this pattern is something unique, this pattern is something yeah this pattern which we have taken, this pattern is something which is repeated next. This pattern is something which is fixed. Now in this pattern you can have any element at the end, so you can end it at 4, you can end it at 5th position, you can end it at 9th position. So you should have all the possibilities. So what I'm doing, I'm just picking this cycle and I'm ending at oh okay, sorry, one thing is there also. So you have this yeah, sorry. Okay, so first position should be first position should have this option. And okay, just try it out, this is the logic, but you need to stop at somewhere. Okay, I'll try to write it in the notes and you can check there, but I'm just not able to write exact thing. But yeah, this is easy, like you have the pattern now, you just need to count all the possibilities, because you are saying you can end it at this place, you can end it at this much place. So you should have all the possibilities, because words are of finite length, but it could have any length, so you should be able to write all the elements. So just try to write using this, but these are not all, you have to consider all the possibilities. And you can check the notes for understanding that. I'll write it there neatly. Is that okay? You understand the logic, right? Okay. Okay, let's move to the last question of this assignment. Let f be a finite automaton such that it has exactly one accepting state. So this is the accepting state Q, and the generating function of the language accepted by it is the generating function is given to be this. Now add a new state Q dash of 2f as in the figure. Then designate Q dash to be a sole accepting state. So this is the only accepting state now. To this new automaton. What is the generating function of this new automaton? So what do you have at till this place? You have this Lx. So you have Lx. Now what you are doing? So for example, this Lx is coming from U. Okay, so you have Lu. For example, because this is a accepting automaton, so you will have some U for this. So you take this U. Now you are adding Q dash to it. So there are two possibilities to go to Q dash, either by 1, either by 2. So you can go by 1 or by 2. So what you are doing exactly, you are just adding 1 or 2 to your U. So next you are going by 1 or 2, because you have to reach at accepting state. That is happening. Okay, so this Lu12 x, what it will be, you know that there's a multiplication, so there's a concatenation, so you can have you can use multiplication thing, and you know that what is Lux, this is 1 minus 1 x minus x square plus this L1 or U, so either 1 or U. So there are two possibilities. So this says you will have to add, or means addition, and L1x will be just x and L2x, because these are the elements of alphabet. So you oh sorry, again there's
Not 2L or 2X.
Yeah. So there's a multiplication. So because there's a concatenation here, so there will be a multiplication. So this will be a multiplication. So you will have 2x by 1 minus x minus s. Is that okay? Okay. Very good. So yeah, this is the end of week 4 assignment. Okay.